Maybe some of your questions might be solved after listening to our next presentation. So now we have Mr. Jose Luis Ondragon. He comes all the way from Mexico, not from nearby, and he'll tell us a little bit about his experience in Mexico because they are producing a digital map. You have the floor. Thank you so much. I want to tell you a story about how we are migrating from proprietary ownership software to open source. The INEGI is the Geography and Statistics National Institute in Mexico. It is an independent agency, so it's state-owned, but it is not, dominated or controlled by the government, and it is guided by the National Act on Geographic Information and Data. And this digital map I wish to talk to you about is something that we have been working on for years with a view to disseminating the use of geographic information among society. So I would like to tell you how we have taken steps to avoid proprietary software to a strong commitment to open source software. I'd like to give you some data, a little bit of background. I want to tell you the reasons why we started with proprietary software and why we switched to open source, and why this is now a platform for future projects. The vision of my institute, INEGI, INEGI, and it's under the Direction General of Geography and Environment. The vision is for geographic and statistical information to be used in decision-making processes in all sectors and industries in Mexico. So we've had different agencies in Mexico that have depended on specialists to obtain geographic and statistical information. The idea is for all the industries and sectors make the most of said information. There is an act, a law in Mexico called the Act on the Geographic and Statistical Information National System, and Title II talks about specifically the following. Chapter 1 on the system, Article 3 says that this institute has as a goal to supply society and the state with quality, pertinent, true, opportune, and appropriate information. The system has 4 goals. Number 1, to produce information. Number 2, to disseminate information appropriately through mechanisms that are enablers, to promote the knowledge and the use of information, and finally to preserve information. So items 2 and 3 of these goals established by Article 4 are especially important because we have to really make headway as regards disseminating information and making it available for consultation by one and all. GISs have always been important. Here you have a timeline you see that ever since 1989 we have published numerous systems to consult geographic information and also geo-referenced statistical data. However, in most of these systems here don't use open source that much. Over here, there's 3 systems that have used open source. And here in 2002, we have a first version of Mexico's digital map that was produced at the beginning with proprietary software. We wanted a web-based information system so that the only prerequisite would be having internet connection. The main goal back in the day, although this changed with time, the main goal was for users to be able to consult all the acquis of Mexico's data on geography and statistics. The idea was also to include layers with statistical information and have everything in a map. The first version was performed using proprietary software, and we obtained a license from a map server. I will not mention the company, but most of you can more or less guess who was behind this. We started working with JPA files, and then we moved to a proprietary database software. This is the first version, and this version only worked well using this browser, which was really the only one that worked well in Mexico. What advantages does using proprietary software pose? Well, number one, it was an out-of-the-box solution, so it was easy to install and run in minutes. And it could be set very, very easily. Nonetheless, there were some drawbacks. One was that being an out-of-the-box solutions, we could not generate new functionalities. The only thing we could do with the system was what was already in the box, so to speak. And although we wanted more functionalities to benefit users, this was impossible. It was absolutely impossible to generate new functionalities. Another disadvantage was that to have test or development to run tests, we had to wait. So we were not free to do whatever we wanted. And although it was possible to generate web map services, WMS, the software couldn't take as a source certain services. So all data sources had to come from servers that used the same software. This is the architecture of Mexico's digital map first version. This is the hardware. We had the database server. This would be inside, and then outside, the more public server. We had the web map services. It was it had 4 processors. It was double core, and we started providing services with this. Why did we move on to use open source? Well, the first reasons didn't have much to do with the actual concept behind open source. The hardware architecture was not meeting our needs, because the digital map was becoming very successful, and the architecture we had did not allow for an appropriate service provision. It started to crash, it became slow, and one of the reasons was this firewall. So the web map server, when consulting the spatial information, had to process everything through the firewall, and since the firewall per se had to check everything, this slowed down the data transfer. So we designed a whole new architecture, including 3 layers, to have the map server and the geospatial information data on the same side of the network, and a 3rd layer outside that would be the external layer, the client application, so that the vectorial information would not go through the firewall. We hadn't considered changing the software. We just wanted a better performance, so we thought that we only needed to improve the hardware architecture. This was the new design. Again, 3 layers. The geospatial data server, the map server in the same segment, so all vector transfer occurs in the same network segment. It's not interrupted by the firewall. The firewall is right here, and only the built maps had to go through the firewall, had to pass through the firewall, very few kilobytes. So a lot of information could go from one server to the next prior to passing through the firewall. So we started studying which servers we could use, and we decided to use the same software as that we were using. So we had to consider using that software with the new hardware. But we started having problems. According to the software license, the more powerful the server, the more expensive the licenses were. The licenses we had and that we had paid for could not be used. So we would have to discard those licenses. We started to see how much new licenses would cost, and since these servers were quite powerful, here you see 16 processors with 6 cores. The map server were included 8 processors, 6 cores, and there were 3 servers actually, and the application server was 4 processors, 6 cores, and 3 servers. So this was a lot of money. We had spent a lot of money in the hardware, and all of a sudden, to our surprise, we realized that the software was going to be more expensive even. We had 3 possibilities. First, upgrading, regardless of the cost. I mentioned already that upgrading the software was going to be more expensive than actually purchasing these servers I have just described. 2, seeing if there was any other proprietary software that was cheaper. 3, the third possibility we considered was using open source software. It was not the first time we dealt with open source. We had experience in small projects that had turned out quite well. We didn't use open source for the digital map from the beginning because we thought that this project was more ambitious and we didn't have the technical skills. But as soon as we had the digital map, we started conducting smaller projects via open source, and they worked quite well. So we started discussing this with other agencies and institutions that had experience using open source. So we decided to take the risk and go for possibility number 3, using open software for the new version of Mexico's digital map. After some months of development, we had an absolutely functional version to replace the old system. It was full re-engineering. The idea was to have a new hardware and software architectures. We wanted to apply new technologies and use open source software. Here you have some screenshots of the new version. We have the city plan. We have over 30 million building numbers. Let me tell you a little bit more about this. When we started working with the open source software, we had to do more than just open the box and plugging the device in. So we had to spend some more time learning how the software worked. We used a GIS solution based on a service-oriented architecture and an enriched internet application, RIA, Web 2, HTML, and a search engine. So we also used pre-existing tools like map deployment area, zooming in, zoom out, moving around, layer tree, reference maps, symbols, measurement tools, geographic object search, influence areas, and map printing. And this is the influence area. And with the old system, when one wanted to, you double click on a checkbox to activate the buffer tool, and you could create a buffer in the interface. That was all. The buffer was created visually. Indeed, we did the map would open up, and there would be a perimeter or around the area, the influence area, and this was performed by using PostGIS. So we had this buffer, but since we also had the vectorial, the buffer became a new layer. We could do something new, i.e. to match this information with other information data. So it's not only about saving money, which was the main reason for which we started considering open software, but we also had new functionalities and possibilities. This is part of the service-oriented architecture. We started using REST JSON data service. The client was built with HTML5, CSS3, and the servers was orchestrated through Ajax. We used many components, including, these are all, by the way, open source, was a geospatial database based on PostGIS. We used PostgreSQL, SQL, a map server. So we had a pool of connections to geospatial data. It was based on open layers. We used Apache Tomcat and Apache HTTP server for a web server, and for the interface we used jQuery. And there are many other components or development library of the Apache Server Foundation involved in this project. As for the development, services were developed with Java. Some search or phonetic conversion tools were directly developed on the database, and then we used JavaScript for the interface. The benefits of this new software: the agency is now the owner of the development. It can be the information and the work can be shared. We can reach agreements to work together. The components are quite robust. It does not require purchasing expensive software licenses, and we couldn't use the map prior to using open source. We couldn't reach agreements with the old map to share with other agencies, because when we wanted to share the information with the old system, those with whom we wanted to share the information had to pay for the expensive licenses. So now we've reached agreements whereby our collaborators, the people we cooperate with, do not have to purchase licenses. Since it is service-oriented, this makes the integration of additional functionalities easy. Previously, we were tied to products and services provided by the proprietary software. Now we don't need to do that anymore. We are designing projects whereby some agencies are providing WMS services. They can use proprietary software, open source, what have you. It can all be integrated. And also data services, and these web services that they can implement in the language they want, and that connectivity is perfectly possible. Another benefit is that the goal or the concept of this digital map has evolved. In 2002, the goal was to publish geographic information produced by INEGI, this institution, this agency. Then in 2009, the idea was to publish geographic information and statistical information georeferenced by INEGI. And by 2012, the goal was to become the geographic platform to publish the information of the Geographic and Statistical Information National System. So all the governmental agencies that produce this information are included in this platform. So again, it's a platform for future projects. Here you see some of the projects that have used the digital map of Mexico. gvSIG is a tool to produce a census. There were elections in Mexico some months ago, and here you see the characteristics of the population. They can do some polling and design their campaigns on the basis of that information. We just saw another map where coffee is grown. This Mexico Atlas is was done by the tourism department. In conclusions, we were very successful using open software. So open software is robust. The digital map platform integrates over 200 information layers with over 60 million geographic objects, and we've had no problem whatsoever in using it. Also, open source gives you freedom of action. You can install it in any hardware with no restriction. We can use as many test beds and devices as we want. We can develop systems and applications with other institutions without having to pay for licenses. Also, open source makes us more technically able and skillful. The main goal of the main benefit of proprietary software was that it was an out-of-the-box solution, but it was really limiting. And the drawback of open source was that we had to learn more technicalities, but this was very useful. We learned and were able to develop software that we wanted, regardless of what the company owner of the old software decided or had available. So open source promotes standards. The old version didn't allow us to connect with AWMS, so we can use pre-existing data, and whereas the open source allowed for all of that. The Mexico's digital map is a good example of how open source can be perfectly used for public institution, and that it's worth learning more and studying and advancing to make a headway. Thank you so much.